everybody. It is Mike Levin on Friday, October 8th, 2021 at around coming up on 8 p.m. I just dropped my kid off at Alpine Scout Camp up in the Palisades. And so the driving that I just did was coming down the Palisades Parkway and connecting around the New York George Washington Bridge area with I-80 West. Now, I am a seasoned driver. I grew up in the Philadelphia area with the Schuylkill Expressway, the Schuylkill Expressway, 202, let's see, 309, and there were some challenging highways and driving situations in Philadelphia. It had some windy routes and some interesting merges and very unusual ways that lanes appeared and disappeared. And I'll tell you, none of that compares to what I just did with these snaking roads, with these high-speed clover leafing and then clover leafing again, snaking roads to get you from the Palisades Parkway to I-80 West. And so, yeah, 2 hours out to drop my kid off at a scout camp, 2 hours back, and then I'll be picking her up again on Sunday to drop her off again on Monday or perhaps Tuesday, depending on soccer practice and such. And yeah, it's a phase of life. It's fairly challenging. It's a rigorous drive. However, long drives are not what they used to be. With media, either producing, such as I am now, or consuming, such as I do with podcasts like Talk Python to Me, my favorite Python podcast with Michael Kennedy, and all the interesting guests in the Python community working on the interesting and important projects. And I just keep learning more and more, and I just keep, testing and tempering and putting through different cases, input testing my latest non-system system. So when last we left off, I was talking about how I alternatively was creating frameworks or using frameworks over the years. And I have now what you might term as framework exhaustion. I'm tired of things becoming irrelevant, after whatever that platform du jour goes away. So the very latest thing is I just migrated my personal blog that was on mikelev.in. My domain is my exact name with a period before the IN. So MIKELEVIN, period before IN. And that's my main personal domain. And that was a WordPress blog for the longest time. But even just keeping WordPress up to date and plugins working and stuff, when you're measuring time in terms of, years and perhaps even decades, having it out there on WordPress is just kind of silly. It's a lot of overhead, a lot of moving parts, a lot of exposure to risk, when you can just Jekyll transform it into static high-performance HTML pages being served off of GitHub for just the cost of free if your GitHub is public, or if you're like me, you pay your $80 a year to have unlimited personal private repos at GitHub. Now you might say, aha, vendor dependency, just like you keep warning against. You stop paying for some sort of cloud thing and your repos go away. Well, only your private ones, and they probably don't get deleted too soon if you decide to pay again. And also, all your local copies of those repositories are edit by edit, just as valid as the centralized copy repos of your project. Every node is a full project history, so every Git clone is made equal, whether it's the centralized repo one on GitHub, or whether it's the latest time you Git pulled it, say even down to your mobile phone, which I'm doing more often. And so your code can flow. You just got to make sure that you do pull your repos every once in a while to somewhere where you treat it kind of like a backup drive or a vault. So again, another use for your Linux instance running on a container on a device like a network application server, an NAS. So I have at least two things I'll be doing on these LXD instances of a Linux server on my QNAP NAS that have come to mind over the past few videos. One is just going to be an email checking heartbeat. So it comes awake every 5 minutes or so. It checks an email address to see if any incoming mail has arrived, and it does something to broadcast a heartbeat. I'm not exactly sure what it's going to be. It could be tweeting, it could be writing to a log file, it could be some, adding a row to a Google spreadsheet, or incrementing a counter in a cell in a Google spreadsheet. It's completely up to you. Your notion of what a heartbeat is from your running server is entirely up to you. So we'll come up with some notion of a heartbeat, and we'll combine the functionality of checking a particular email address for orders to carry out and doing a heartbeat, because it'll do the email check on every heartbeat. It gives the heartbeat kind of a reason, a meaning. So if your heartbeat is set for every 5 minutes, you go, oh, I've got a heartbeat every 5 minutes. It's some sort of check. And if you wanted it every 30 seconds, so you could issue commands fast and furious and know that it's not going to take any longer than 30 seconds, then you can do that. There's really nothing terrible about that. I would probably opt for every minute or every 2 minutes, because you don't want to be too hard banging on an email protocol port, probably at Google if it's a Gmail address you're using. So that's one of the uses, the heartbeat, the email check. But then the other use, I was just thinking about, what was it that was leading me to that? Because I want to run something on an ongoing basis. Well, eventually it's going to be these SEO style tasks, things like doing different reports or search engine monitoring, search engine position monitoring, that kind of thing. But I had something else in mind. There was a second thing in addition to the basic heartbeat. I said that makes two things we can schedule. So I am talking about these no system systems, and I'm talking about how the magical combination of Python and Jupyter Notebook and NBDev and SQLite Dict all come together to make a beautiful, expressive and powerful environment for doing ad hoc scripts, jotting things off quickly that do various tasks. Say it's a 302 check, say it's a website crawl and checking for the response codes for each page so you can find redirects and such. Say you need to check your canonicals, that kind of thing. You can do just as sort of an ad hoc check under a Jupyter Notebook when you import the proper third-party libraries. And you can take anything that you turn into a report, something easily delivered, and you can schedule it. So that same capability that lets you check an email address can also let you package up a deliverable. Say you use, some sort of crawling, you do some sort of keyword analysis of the data you crawled, you do some sort of SERP check, and then you do some sort of on-page analysis of your competitors that come up in search, for example. You can bake that into some kind of finished report and have it auto email, and then you can have those things delivered on a scheduled basis. You can do this because the language of such SEO automation, data science automation, is increasingly brief and self-explanatory, terse. Things do what they say, they're easy to read, they're not burdened with lots of loops, lots of deep nested loops. You don't have to break out lots of separate functions, but it looks like a beautiful jotted off statement of here's how you produce such and such a deliverable. You do a crawl, you do, the fetching of the data from the crawl, you do the storing that locally, you do some word stemming, store the stemming in a separate place locally. You have a series of local databases that you sort of wash and mine materials to from one directory to the next. So you might have a series of directories like keywords and sites and crawls and extracted data or SERPs or extracted metadata. So you have a series of directories that roughly equate to, the kind of data you're going to be pulling. One for raw, one for extracted. And it's all about fetching raw things first with splattable API calls, right? Okay, so the pieces that are working together so very beautifully. I talked about a bunch that let you do the type of work I do. Data, it's really, data collection work, data processing work. And, data processing used to have such a negative connotation because it really meant you were a data entry person. So even though you were a computer person, you were the lowest of the low. You were taking a stack of papers on the left and you were typing all that data in. You were a data entry person, a worker elf, an API for the still unautomatable. So now, in the modern world, so many things are already, they exist first as data. Things like Google Analytics, Google Search Console data, your log files, etc. And so the ability to look directly at that data, to do away with the data entry part, and to do all the insightful stuff, all the fun, figuring out what that data means, what it's trying to tell you, and what decisions you can now make based on being equipped, based on being properly equipped to answer questions with that data in front of you. And if that data is not in the form to answer questions, it's also in my realm to do whatever preparations. You bake it into some, magic 8-ball question answering machine. And there's various ways of doing that. And there's ways that I currently do it, and then there's ways that I see myself moving towards. So there's this thing called Streamlit, which I'm really drawn to. It's a way of making interactive dashboards in Jupyter Notebook. One of the pieces that falls together is that all these complex JavaScript libraries like DS3 have been pre-baked into other libraries like Bokeh and Matplotlib and Sebring that you really don't have to know much about JavaScript to get the benefits of pretty charts and graphs rendered out. Even interactive ones with things like, gravity and collisions and all that, physics. And I'm really looking forward to doing that. I know all about these link graphs and the different data shapes you usually have to transform your data into to load into these visualizations, these node graphs. And it's usually JSON data, which is no problem. You just JSON load and dump, or loads and dumps. The S at the end of these methods for loads and dumps of things like JSON and also pickle data, I've come to understand that the pluralification is very misleading. Without the S, load and dump, like pickle.load and pickle.dump, it tries to keep it, I believe, as binary data. And when you use the S, it's telling it it's really string data in there, as opposed to, binary data that you'd really like to preserve some of the, more invisible meta internals. So things that come clicking together in this environment. So I've been wanting to use SQLite for a long time, but one of the biggest sighs of relief in all of my tech career has been doing less SQL. I have generally done raw SQL strings. I build my own SQL strings, and people would go, oh, with things like SQL Alchemy, you no longer have to do that. I would be like, yes, but now you have to get familiar with a specific SQL API, ORM, object relational mapification, and ORMification, a third-party syntax and API that you have to get used to. And while it might have much in common with other ORMs, object relational maps, you can't be assured that by learning SQL Alchemy that you're learning TinyDB and all the other SQL ORMs that are out there. And, it's not timeless knowledge. I've been very hesitant about bringing SQL back into my life, because to do so, you need to tie your knowledge and know-how. As popular as the SQL language is, you have to tie it to some particular implementation, some snapshot in time that you're using right now at this job, and you'll probably never use exactly that way again ever in the future. Maybe you're on the Microsoft Transact dialect of SQL today. Maybe you'll be on the Oracle dialect tomorrow. Maybe you're using SQL Alchemy today, but maybe you're trying to do something much more lightweight tomorrow, and you use one of the more minimal ORMs like TinyDB. So I don't like that stuff. It's not timeless. It's not cutting across disciplines and the ages. However, the plain old Python dictionary data type, the dict data type, is key value pairs. It's a database in everything but persistence. So pip install SQLite dict, and now you've got a persistent dictionary. Yes, ladies and gentlemen, if you use with and not open, usually you see the with keyword used together with open on a file or a database connection or something. So in this case, the open API is built into the SQLite dict client. So I actually rename the client on the import. I like all just, SQL dict, because you've got, ordered dict, name tuples. So it seems to me, SQL dict without the word light in there. So I very typically now, almost in every case now, my framework is now, 80-20 rule. 80% of the work is done by my first 20% of my imports and coding. Topmost among them is from SQLite dict, import SQLite dict as SQL dict. Okay, there's some capitalization nuance there, but that's something you'll be able to do after you pip install SQLite dict. And now, with open SQL dict file name as db : indent, and anything you do now using that db file handle, that open SQLite database connection, will be reflected in the actual persistent database, so long as you do a db.commit, and you have to call it. It's a callable method. So one of the details here is that while you'll have a dict in memory under the context manager, as you manipulate key value pairs on the DB dictionary, it will not be committed to the drive until at some point you do a db.commit, open close parenthesis. And at that point, whatever you did was now committed to hard drive, and you can get it back out just as easily using the same context manager with SQL dict file name, same file name as DB, the same DB, But now as you plug your keys in, you get the data out that you put in before. It's persistent dict, and dict with memory. Automatic free caching on everything. There are so many implications of this. So what this dovetails together very nicely is, okay, how to go about this. Key value pairs lull you into thinking a key is necessarily just a single value, like a string. A URL would be a perfect example of a key in a key value pair. The key is the URL, and then the value coming out is the web page. The whole internet, the whole web is a key value database. URLs go in, pages come out, key value. And the U of URL is for unique, right? So keys have to be unique. So again, all the more reason the web is a giant key value database. Now, of course, we know there's more to the story. These URLs often have parameters, so a single URL can pull up unlimited potential variations of itself. Say you got a calendar and you just feed in a date, and you can just scroll forward and back through a calendar in time. So a single URL with different date-time parameters, or even just date parameters, can create potentially infinite output. And if you put a next link and make it crawlable, it's infinite output with ultimate click depth from a crawler. I should probably program some of this to demonstrate a crawler getting stuck in a spider trap on a calendar with forward, next, and time links. Classic situation. So, I was saying something interesting there, the key value stuff. Oh yeah, so keys can be made from multiple components. You can have what is essentially a multiple column key. But how do you have columns in a value that, goes in a dictionary key? That has limitations. It has to be what is called, it has to be immutable, an immutable object. It has to be able to be pickled. It has to be able to be serialized. It has to be turned into a binary object that you can just load into memory again. This is where all that pickle fear, stranger danger, pickle fear exists in Python. People are scared of pickling and unpickling data because, unpickling data runs whatever Python code has been pickled. That's how you create objects back in memory. They're high performance, they're not sanitized. However, if you're making a system for yourself, it's absolutely fine, right? So we're going to be pickling our keys because they're built from multiple components, which are not standard strings that are the classic thing you would use in a dictionary key for a unique value. So say you have two columns you would like to use in your key. The temptation is to append them together as a string with maybe a hyphen between them. But why, when you can keep them as discrete element types by just using a named tuple? Okay, you could use a normal tuple. Now remember, a tuple is much like a list, but instead of being dynamic, being able to append things to a list, or even dynamic like a set where you can add things to a list, you cannot do that with a tuple. You can plug things into fixed locations. So say you had a tuple that was, set to be 5 spots big. You could place things in location 1. You can place things in location 2 and 3 and 4 and so on. And then that resulting tuple can itself be pickled. And when you unpickle it, it comes back into the original tuple shape with its values in there as you pickled it. Now there is some nuance here. There's some subtlety. It has to remain immutable. That means you cannot put lists, references to a list, inside a tuple. It is a dynamic data type and will resist pickling. You can put tuples into tuples, and you can pickle that. Nested tuples are fine, but lists inside of tuples, or lists inside of anything, really shouldn't be pickled, because there are links back to other objects that are never really finished. They're not snapshotable. Excuse me while I sneeze. Sneezing on the highway while shooting a YouTube video. Smooth. Yeah, I just don't edit. As we forge on. So, if you picture a tuple like, two test tubes end to end, or opening to opening, it's not flexible like a slide rule where it's got square on each side, and slide rules can slide closed and open. So slide rules are like lists. They've got the square brackets. They're dynamic and open-ended and mutable. Lists are mutable. Then you've got tuples, which are made of glass, and if you put two of them mouth to mouth, you don't have much flexibility in there. You've got a fixed amount of space inside of there, and the underneath of those test tubes are kind of curved like parentheses. So that's where you got your tuples. Tuples are like capsules. And then dictionaries are like JSON objects. Okay, but we're talking about tuples. Tuples are perfect for feeding to APIs, which are, the way you define the parameters and arguments of your functions. Now, it has other meanings out there in this web world we live in when people talk about APIs, and especially RESTful APIs and open APIs. They're talking about making requests specifically over the HTTP or HTTPS or generally TCP/IP protocols over a network to very loosely coupled components that are located around the network, around the world, what have you. Potential higher latency of communication between parts because it has to go through the network layer all the way to TCP/IP, all the way to TCP/IP, from TCP/IP to HTTP, and all this overhead of all these conversions that take place as it travels through the network stack. Not particularly high performance, however, it's the way much of the web works these days, programming things as microservices, so it doesn't have to be components within your local Python program. However, not everything is web development. In fact, I'm a big advocate of non-web development, because first you have a simple project, and then you try and make its components talk through a internet protocol, and now you've got a complex project. You've got to choose, a web server component. You've got to choose your interoperable languages. It used to be Whiskey for web servers talking to Python. The Whiskey web server interchange. WSGI web server gateway interface, Whiskey, WSGI. Now it's changing to ASCII, the asynchronous server interface, something like that, gateway, to deal with asynchronicity, right? So you need to, if you choose a web server, if you choose to have your components talk to each other through TCP/IP or any web protocol, now you need a web server. You got your web server, now you need your protocols for it to talk. It's probably going to be ASCII. I got to keep it straight because there's ASCII, ASCII, which is old school 256 character style ISO Latin 1 set of characters, A through Z, and a bunch of common, Western characters, thrown in. That's ASCII. But there's now ASGI, which is the asynchronous gateway interface, which is replacing WSGI, the web server gateway interface. And so that's the protocol, or the API, with which Python talks to web servers. So that would be between, say, CPython and Nginx, or GNU-icorn, or Apache, or things like that. And now you've got the questions of whether you're going to do streaming or not. So there's asynchronicity, and then there's streaming, and then there's open API. Are you going to publish your protocols? How published and out to the world facing do you want this? So basically, you've taken a simple project which you could just code something up into under a Jupyter notebook, and you turned it into this big complex thing with lots of moving parts and a lot of server context that may or may not be there when you need it. And I don't like it. So oftentimes it's simpler to just keep something as a local application. Your components and your parts that are talking to each other, potentially through different APIs, are your pip installed packages, which get included at the top of your file. So, import pandas as PD is a very common one these days, to get the pandas data science libraries for matrix analysis type stuff, row and column type stuff. Stuff that you would often have turned to numeric arrays in the Python third-party compiled C high-performance NumPy library for. You can do now with a better API layered on top of it, and more data type handling and special data types like data frames created that resemble, row and column tables in SQL or Excel tabs. And suddenly the Python environment becomes a viable alternative to Excel or Google Sheets, for that matter. You start thinking and behaving with your data with as much confidence in its reality, its usefulness, its accessibility, as you generally expect to feel from a spreadsheet, because the numbers are right there in front of you in rows and columns. So people feel really good about that. It gives you a feeling of control over the data, because your muscle memory with that mouse and pointer tells you exactly where to go, what to look at. You can look across your tabs to see what data is there. If you're worried about data that you're not seeing, you can look for hidden tabs. And, you can examine the formulas and cells and stuff. So people have a pretty warm and fuzzy feeling using their spreadsheet interface. Humans love spreadsheets, ledger sheets. It's accounting stuff because of the accountability of it, right? It's out there, it's in front of you, it's not hidden away. Now, that only carries you so far, because the methods of automation resist or balk at the loosey-goosey methods of desktop spreadsheets for a variety of reasons. It's a whole video right there. Let's just say, if you keep your data from having to live in a spreadsheet up until the final mile of baking it into a deliverable for use by your stakeholders, by your non-technical folks who are going to want it in a spreadsheet or something like it, you'll be better off. Make that data look and feel and smell and taste 100% accessible to you, as useful to you as if it were in a spreadsheet, but with it not being in a spreadsheet, with you being just a technical person who uses some very reliable and very rote and very self-descriptive and self-explanatory ways of managing your local back-end data, which is, ends up being kind of like a cache, kind of like a long-term option for memory storage, for database storage, a junior enterprise, system that you could probably bake out of SQLite. staging it for becoming a mature enterprise caliber piece of software by making sure you don't do stupid coding, making sure you program most things without stateless. If things are programmed statelessly so that they can instantiate, do their job, and disappear, especially if it doesn't have a large time delay to it, if it's got a bit of optimization to it, good techniques used inside, like a lot of list comprehensions, then you've got something that's going to be scalable in all different ways. There are multiple dimensions to scaling, but your first line of defense is keeping your smallest unit small in memory, small in code. When you instantiate 1,000 of them, it's going to be that much smaller of a footprint for each of those 1,000 that you instantiate. And you'll scale larger, you'll support more requests per second or whatever your metrics are. And you set the stage for these things, even though you're not really building everything out that large, but you're building small, you're building in, I keep using this word ad hoc. What I mean by that is interactive work sessions where you figure stuff out for the first time together, oftentimes writing code from scratch without copying and pasting off of Stack Exchange and Stack Overflow and all those pages you're going to Google up. I'm talking about internalizing enough of the best parts of the best APIs such that you can just jot things down naturally and define a whole SEO deliverable. I'm going to talk in terms of my field because it's what I know best. So, one of the challenges I have right now is that I've built a concurrent page fetcher, get responses. And you feed this get responses function a list of URLs, and it concurrently crawls them all and builds a list of responses. So you give it a list of URLs, a list of requests, a list of URLs. URLs are requests of the get method. And then you use this concurrent HTTPX getter that I've written. And it uses all these techniques I talk about in earlier videos. The async keyword on the context manager. So it's a async function being used with the context manager for all its cleanup, connection opening and cleanup work. And the await is further used on the internal loop of the file handle that's created with Context Manager. Now, this might sound like gobbledygook to you, but there is some magic internals going on here where you're basically saying, here's a list of URLs, fetch the contents of each of those pages. However, do not do it yet because asynchronous. It is now a promise. Now, people talk about the async and await keywords under JavaScript and Python as if it was getting rid of promises. JavaScript had this whole promise. At first it had callback. First it had nothing. Then it had callbacks. And then callbacks became promises. And then promises became async and await. And so now the common way of thinking about it is that the async and await keyword in JavaScript does away with promises. Well, no, they don't. And it's the same way in Python. Async and await just hide the word promises from you because what you're awaiting is a promise. You're awaiting the returned values on a promise. So when you instantiate, when you call an asynchronous function, if you don't await it, it is a promise, okay? Which opens the doors to some very neat tricks because you can build lists up here in your synchronous code, in your default, how a notebook starts out, because Jupyter notebooks in particular are synchronous, they are not asynchronous. Async await does not fit well, certainly did not fit well inside of Jupyter Notebooks because of the context of the event loop. One executable, one master event loop that opens at the beginning of execution and closes at the end. What's the close at the end of a Jupyter Notebook? It never closes. In a REPL environment, it's like keeping an open connection to a database. You start code running and you never finish it. That's why you can keep inspecting the values of variables that are sitting there. Python.exe has not come out of its event loop, out of its code execution run. It's still running. That's why in Jupyter Notebook, your running kernels actually do take a lot of memory, because each one of them is a whole Python virtual machine. When they say kernel, it's a running instance of a Python virtual machine, isolated through sandbox methods from every other Python virtual machine. It's just like the tab, comic book of when Google Chrome came out, explaining the software sandboxes that allow little JavaScript code execution engines to not blow up the whole web browser. It can only crash a tab. So same thing with Python kernels under Jupyter Notebook. And the reason why multiple tabs in your browser take a lot of memory, and multiple tabs under Jupyter Notebook take a lot of memory, running kernels. So things are getting slow, close out of your kernels that you're not using anymore through the Jupyter interface. So async and await were a problem under Jupyter Notebook. You had to monkey patch near the top to keep an event loop that you could actually use in a Jupyter session, work sessions, ad hoc work. You're in a Jupyter Notebook, it's still running. It's the REPL environment, read, eval, print loop. It's always checking, it's always interacting with you. You can always check the values of variables and objects as it's going. You can dir things and type things and learn a lot about the environment your code is running in. However, it's very difficult to keep straight in your mind, and even harder to keep it all working correctly, asynchronous behavior under such an environment, right? REPL is almost sequential by nature. REPL, read, eval, print loops, Jupyter Notebooks are almost inherently sequential. Because when you do concurrent things, there's a large degree of trust involved in the environment to handle those things that must be pulled off without a hitch with concurrency. Enter the context manager, okay? It was very difficult for me to wrap my mind around asynchronicity, in general, much less under Jupyter Notebook, where by design, event loops are foobarred. What event loop? The event loop for the, main Python.exe, running thing? Well, as soon as you interact with it, now, when does it exit? Things happen when you exit event loops. When does it happen? So something happened in Jupyter Notebook between my previous experimenting during the times I had to do the monkey patch on the event loop, and my current times during which async and await just works the way you would expect it to work. There is some magic Jupyter fairy dust being sprinkled in, some IPython engine fairy dust. As well, there's other places this is done. The magics do it when you use these special percent symbols to feed behavior changing, information into Jupyter. You're doing this too. So there's always different, slightly different, slightly modified API to Python under IPython and Jupyter Notebook. That's just the way it is. So among the things they did is apparently cleaned up and made meet expectations the default generic main event loop, which is tapped in doing concurrent behavior, non-blocking behavior. Now, there's a lot of words thrown in here into this word salad of concurrency, and it does not do it justice without pointing out that you have to be very aware that there's different things potentially being talked about here. There's concurrency, where code is seemingly running together at the same time, but it does not always necessarily mean you will get twice the execution time by breaking it into two. It will oftentimes make things seem faster because you don't have to wait. You don't have to wait for thing 1 to be finished for thing 2 to occur. This is non-blocking. And so for things to be concurrent in the non-blocking sense, doesn't take a lot of processing power. To make HTTP requests, which have all this network overhead, seem much faster, you do it concurrently. And if you want to do it faster still, you do it under the same client or session environment. The requests object calls it session, or the requests package from Kenneth Wrights calls it a session client. And then the HTTPX package, which I'm using more and more, calls it an async client, I believe. So a session and an async client are all your HTTP connection context stuff that can be reused between page calls. The same headers and stuff like that. You know, your cookie information survives. If a cookie is set on a response, those cookies will be used on the next request inside one of these sessions. It increases performance too. So if you throw on all the stuff to speed up concurrent HTTP requests, you can get a whole lot of data really fast, and you still have hardly even tapped the processing power of your computer, the CPUs in your computer. You've probably still just tapped one of your CPUs, and it all just seems remarkably faster because non-blocking I/O. Multiplexing, not multitasking, I am afraid to tell you. And in fact, anything that has the word thread in it, especially operating system threads, but threads in general, have the risk of being just non-blocking and not actually internally that much faster, aside from the non-blocking effect, which makes it seem faster. To get actual speed increases, the keywords you want to look for is multiprocessing, multiprocessor, multiprocessing. In other words, whole new Python.exe kernels, like just the way Jupyter does it. If you have multiple kernels running in Jupyter, that's running in parallel. If you have multiple cores, then each one of these can hit against a different core, and bam, suddenly you've not only got, non-blocking, but you've got parallelized concurrency, and that's much better. You don't often get that under Python or under JavaScript or under many environments in general, unless it's specifically angling for that, unless it's made to get that. And there are a few that are. I believe the Go language is. Erlang might be another. There's a few that take their multiprocessor concurrency very, very seriously. And okay, so going down that path. So there's APIs to access all of this. There's one API to access easy non-blocking concurrency. That's what I'm doing with HTTPX. And the get responses function I wrote in order to be fed a list of URLs and to get back a list of responses as fast as possible. Now this gets to some interesting challenges, some things that I need to figure out how I'm going to do it canonically within my non-system system. So when you're just doing lookups against URLs, HTTP, no problem, your keys can be strings. when you're doing lookups against URLs that are built out of two things, say a site and a keyword, for this site, now, even though you could build that into a URL and use that built URL as a key, because it's unique, you wouldn't want to, because to get those keywords or those sites back out of the key is not easy. You would have to parse that string. You would use URL parse and, basically deconstruct things, and then order sensitivity of how you constructed your URL comes into the picture, and it's just an awful mess. You just don't want to do it. You don't want to extract discrete field or column information back out of a compound's primary key that you sort of magically blended together into a request string, into a URL of the get method to perform a Google search, for example. Rather, you would want to store a named tuple. Now, remember how I told you tuples have fixed positions? Something in the first spot, something in the second spot, something in the third spot, and so on. Well, how do you know what these first spot, second spot, third spots are? Well, go look at the named tuple subclass or variation on a tuple. It's tuples with labels. Each of those positions in your tuple, first it can be defined. You can state what your tuple shape should be, saying, here's the label for the first thing, it should be a keyword. Here's the label for the second thing, it should be a site. Site is optional. If you provide just keyword, it will work. If you provide keyword and site, the query string will be built slightly differently. So you've got a named tuple called key with its first position labeled keyword and its second position labeled site. You can create instances of these named tuples by just putting the parentheses around the values you're calling with the name of the factory class in front of the parentheses. So in my case, it would be key. I create instances of the uppercase KEY factory class with key instances, lowercase KEY, which have a particular keyword in the first labeled position and a particular site in the second labeled position. Now you got a tuple. You got an instance of a tuple object. You can treat it just like a tuple, but profoundly coolly, you can use it as the key in a key value pair of a dictionary, which means you can use it as a key in a SQLite persistent dictionary. But you can't just drop a named tuple in as a key. You first have to pickle it. So you need yourself your pickling and unpickling functions. You could probably use decorators. I just use the functions. It's easy to put, the characters PKL parentheses around any key going into a database key value pair. And so DB square brackets PKL parentheses key instance of your named tuple equals, well, you don't have to set it equal to anything. You can set it equal to none. And if you do a spin through your list of keyword site inputs, list of keywords, list of sites, you will then have a SQLite database that has a record for every API call you plan on making, with the tuple that you can feed directly into the API used as the database key. Now you can iterate through your database keys and splat your key into the function. That is, instance of key put inside the parentheses of your function call, like perform search. And you put an asterisk in front of your key instance name, and it unpacks the tuple into the API, into the compatible API of your function. And now you've got values. You set the DB, of that pickled key equal to the output of that function. You commit it with a db.commit. It's now on the hard drive. The next time you iterate through that database object, you have all the responses to your API calls. Now you got a cache, ho, ho, ho. Now you got a local SQLite database, ho, ho, ho. Now you got all your raw API responses, ho, ho, ho. Now you've got a record of all the API arguments that were used to create those responses, to fetch those responses, ho, ho, ho. So this defines a way of working that over time, as it seeps into your muscle memory, becomes as clear as data in a spreadsheet in Excel in front of you. You might not think so, but once you learn how to iterate through one of these SQLite dict objects with a context manager with SQL dict, file name as DB for key in DB, value equals DB square brackets key, you know, do with it as you will in the loop. I'm just waiting for list comprehensions in combinations with a context manager. I ought to check that out, see if that's possible. I do believe I've done that experiment before, which implies, by the way, okay, if you want some profound magic voodoo, okay, in the Python API, one of the most powerful and memory efficient constructs I can imagine is, we've talked about list comprehension, right? Take a list, do X for X in that list, and put square brackets around it. Now you got a list comprehension. X for X in list, okay? That should be able to, well, first of all, you can turn it into this, instead of the square brackets around it, you can use parentheses around it, okay? So that implies a tuple. So when you imply a tuple, you're implying certain other things too. You're implying a certain level of memory efficiency, a certain level of willingness to let go of pointers, a willingness to live in a much more static, defined NumPy array-like state than the generally more dynamic loosey-goosiness of a Python dynamic mutable list, which you can't even pickle. So that's why things built from tuples are pickleable. They're much more static in nature than lists. And so when you build an iterator, that's what these list comprehensions are. List comprehensions are just another way of stepping through every element in an object, right? That's what a lot of these things are. They're shorthand syntax for creating loops, right? It's creating loops. So when you use list comprehension syntax with parentheses instead of square brackets, you've created a generator. It implies generator because what are things like tuples that are memory efficient good at doing? They're good at letting go of their sources of data. They're good at being forward-only fire hose pointers in the SQL context. So you could say, for each line in a million or billion line file, write line, and it'll just work like a streamer so long as it's parentheses around it, because you've just built a lightweight generator. Now, this is not a Ruby on Rails code generator that spits out scaffolding so you can program lazy. No, no, no. This is a Python value yielding generator, freezing the upper context to return a to momentarily return a value under the lower context while not worrying about the upper context anymore, knowing it's taken care of, it's closed out of, it's frozen, it's otherwise not going to blow up the memory on your system by stepping through millions of these. Now, you'll blow up your Jupyter notebook if you're printing 1 million lines into a notebook. But if you just loop through it without display, if you loop through a generator without displaying its output, you can loop through, 1 million, 1 billion, try and get up to 1 trillion, see how long it takes. Basically with a for each element pass. And you'll kind of get a sense for how fast and efficient these, non-looping loop APIs can be. So, the most powerful magic is if you do one of these parenthesized list comprehensions. If you were able to use the with async as, if you can use the context manager in asynchronous mode inside a generator comprehension. If this works, and I still do have to test this could be one of the most beautiful statements in all Python, because it loosely says, fetch all the data as fast as you can and flow it in the most parallelizable way you can through the APIs provided by your database level that are taking responsibility for all the writes, be they concurrent, sequential, and all the cleanup and closing work afterwards when you're done. So you could probably crawl, say, a 10,000 page website into a local SQLite database with one elegant command and not much time that you'd have to wait while it was being carried out. So lots of people use Screaming Frog. First, you need a desktop. Okay, so there's implications now on running it in server context. You can't just automate anything you build that has Screaming Frog in it as a part of the process. Well, you can make your server instance something with a desktop. You can make a Linux desktop, like Ubuntu desktop as your server, so that you can have Screaming Frog come up. Maybe you can run Screaming Frog headlessly or command line. But now you got to pay your Screaming Frog license. You've got to pay the proprietary piece. Screaming Frog is written in, I believe, Java with a Swing API, which is a little bit slow and kludgy and doesn't have the native operating system advantage. And you can really feel it. It's like your cursor stuck in molasses, even with the modern, the speed of modern machines. Apps built out of Java, desktop Java apps feel clunky. Screaming Frog is one of those. So you got that overhead of the whole Java runtime engine and all its Java user interface work for Screaming Frog. Maybe you don't. Maybe you run it headlessly, then you just have the JRE in the picture. Just like when you're doing Selenium automation, you always have Java in the picture. Or when you're doing Endeca or Elastic Search, the free and open source version of it, you always have the Java overhead in the picture. And when you're a Python person, or when you're doing Hadoop or Sparks and stuff like that, and you're going through wrappers, and you're using the Python API, especially for Sparks these days, that seems to be pretty popular. Underneath, no one's going to rewrite the original Java stuff, so you are instantiating a whole runtime engine. But why be a purist? If it's working for you, do it. Hey, I use Jekyll, which instantiates Ruby on every static site generation, but it's only once on the static site generator. So anyway, there's so many sub-nested discussions here, and so many purity issues, and so many optimization issues, and philosophical issues. And philosophically, I'm trying to minimize my dependencies, maximize my performance time, maximize my lightweight ability to automate anything I do, minimize the licensing costs, the database, the tech liability that comes with server instances that I might want to scale out by the thousands if the thing ever goes prime time and big time ever. But most of the time I want to do just a humble little Jupyter Notebook ad hoc work session together with a stakeholder as we sort of feel our way through and maybe do some new invention, maybe add a layer of natural language processing that I didn't have before, add a new field that's built out of these three other fields being word stemmed and longest sequence analyzed. So all this stuff becomes really terse and brief and sort of breezy, if you will. Easy to read, easy to write from scratch each time, and that's an SEO deliverable. However, you had to pip install, pipulate, OAuth, SEOML, one of the many other libraries I've been working on, and I think I'm going to wrap them all under Pipulate. It's got the most stars in GitHub, it's got the longest history, it's got the coolest name, I've got it as a domain registered already. It's got a lot going for it. I can try and keep API compatibilities with existing implementation installs that use Pipulate, because I do have Pipulate out there. I have a few people using it with the existing API. It's a little bit scary that I built something that people actually start using and in production too. So yeah, cleaning up Pipulate, keeping the API as compatible with its current form as possible, and maybe layering in something that's normally done when it's a web API. The idea of Open API appeals to me. Now, Open API is something that documents your API, so people can make a request of your API and it answers saying, oh, I can do all these sorts of things, and it helps auto, documentation systems. It helps auto completion systems in IDEs where you're importing a library that has a well-defined IDE. So enter NBDev again. NBDev just completely dovetails with all the elegancies that I'm trying to get into my workflow. So when you have a bunch of libraries like Good URL and Crawl Website and stuff like I have, you want to start building them into some centralized thing so you can get them all at once. Pipulate, pip install Pipulate will give you all my best of my latest stuff as soon as I wrap it in. Pipulate will be moved under NBDev, so moving an existing deployed package that people are actually using to be under NBDev with a little copy-paste job. That's a video coming up, one of the most important pieces of work I'll be doing. Free and open sourcing some components of my SEO toolbox that I have not before, or that I have only done in very old forms in Pipulate in the past and have subsequently, pulled out because of changing world issues. A crawl of yesteryear is not a crawl of today. So I want to use my new SEO kata that I've been describing to you over the past few videos, where everything is back-ended under these light, breezy SQL dict statements that first does a, API call named tuple generation pass. So you generate all the named tuples that'll be splattable to make your API calls. It's like, what API call am I going to make? Oh, well, what values do I need to feed into what functions to do that? Here, this is it. You got to call this, first you got to get the data from, an endpoint, an API endpoint, like Google search. Next, you got to store that data somewhere in preferably raw form. There's often a question here, do you store it in raw form, or do you go just for the values you need and throw everything else out? Well, you store it in raw form. You don't only store it in raw form, you store the response object right down to the response headers. And the URL of the request is in there too, and there's all kinds of goodies. So you now have the tuple that was fed into the function to make the request, and you have embedded into the response object the URL that was actually used to make the request. You've got such accountability. You've got the request headers that were used to make the request. You know what browser you were cloaking as. You have, you know, any cookie information, any session information that you sent up on the request, whether this was part of a larger set of requests under the same session or client, a async client. And you have all this sort of flood filled in super fast because you're using non-blocking I/O. It's not particularly parallelized using your multiple cores yet, because it does not need to be. You're going to get killer performance by just squeezing max performance out of your one CPU on your one thread that the global interpreter lock makes sure you have. So even when you're doing concurrency with async I/O and async await under Python, you might think you're like getting parallel processing and getting around the GIL or something like that. No, you're still in a single thread. You are multi-process. You are multi. Get the language right. You are doing non-blocking I/O under a single thread that is kind of multiplexed in order to simulate multiple threads on the same CPU under the same global interpreter lock session. Okay, I probably should wrap up pretty soon here. You can get concurrency if you want to. You won't need it at this point, but you now have an easy to use everyday API that's breezy and light, that's terse, that you can, you know, jot off complex deliverable building instructions during a work session, doing it from scratch without having to stop and check the documentation every time, and without having to look at the source code every time, where auto completion of even your Jupyter Notebook environment will try and step in and help you. And you'll get this auto completion because you lean into what NBDev is trying to get you to do. So if you follow all of NBDev's configuration file tips and pointers that get put in place by either cloning their template out of GitHub or by doing an NBDev new command on an active GitHub repo. It's got to actually be a GitHub repo, not just a Git repo, with an endpoint, with a remote Git endpoint. I'll get into that a little bit later. But when you have that situation and you do a NBDev new, it creates all its template files in location. And there's a lot of interesting little template files here and a lot to learn. I believe it's setup.ini, which is the one master template file for everything. But it's really worth poking around everything else, seeing what is done with the _init files, dunder init files. Look at those dunder init files. Export a library with NBDev build lib. Watch where it puts its files. Check the changes to the dunder init files. And see how it's leaving a breadcrumb of hints for all the things that are going to interrogate this package, for knowing its properties and methods and its internals, and building documentation out of it and using it for IntelliSense style auto-completion. You are trying to make a delightful experience for your user by defining your API. so that it hits the center of the average distribution curve of how people are going to be using it. So the most common cases are the most easy to remember and the most easy to type. The edge cases provide, using previously unused, perhaps named arguments to override their default values. You will be aware of the default value by what comes back through. Oh yeah, I want to use Open API. Even though Open API is mostly used in reference to web APIs, mostly under Fast API, which has popularized it. So Fast API has come along and has popularized a bunch of its underlying components. One of them is Pydantic for data type validation. Another one is Starlet for, I believe, the concurrent calls, if I have that right, for the particular flavor of asynchronicity that's being used, the web server-ish stuff underneath. And let's see, Fast API is popularizing Starlet, it's popularizing Pydantic, and I guess So if you are building something as web services, web microservices, or actual just normal websites, relying on something like a web server in the picture and communication between Python and a web server, you would now introduce something like Fast API or Flask or Pylons or something like that into the picture. However, I do not like doing that. It explodes the complexity and the moving parts of a project. And so your APIs are built for just, private Python executable use to be used as imports. And I still wanted auto-documenting. I wanted auto-documenting like Fast API is auto-documenting. But I don't want it producing web pages at sites like Fast API does. I want it auto-documenting to people who are using it like in Jupyter Notebook. So the auto-documentation comes in the form of built-in help. So when you dir it, or when you REPR it for the string representation of the object in memory, or when auto-completion IntelliSense type stuff kicks in, I want that to work correctly and be a wonderful, delightful form of exploration and discovery. And then actual auto documentation features that build your docs from out of this the way I believe NBDev does. NBDev creates a version of your documentation from your doc strings. It gives you another version of it on as your GitHub README, but from the index.ipynb file that it puts in place as part of the template. And I feel like I'm starting to ramble now. However, it's not so much off my exact point. It is very much spot on. This has the sharp edge of a knife to it with a point I'm trying to make here. A number of different disparate component parts are coming together, and the whole question of what to pick, what to use, what to do has clarified in my mind, with the first highest level being Linux, Python, Vim, and Git, Adoy, and then the next level down from that being, let's see, people are making some weird slowdowns here, cutting in lanes and stuff. Okay, let it happen. All right, so the Linux, Python, Vim, and Git in their most generic forms for first pass, that it guarantees you a whole ton of things of timelessness and obsolescence proof and muscle memory development and getting better at things over time. And then your next pass is accepting the web and web user interfaces in general, and with that, Jupyter Notebook. So you have the REPL environment of Jupyter Notebook and Python inside a web browser. That's the next thing. And then after that, I would say Python pandas. You definitely want to be able to deal with SQL-like row and column data easily in CSV files, loading and saving CSV files with ease, and all that SQL-like join and union stuff. And after Jupyter Notebook and pandas, the next thing is really you want SQLite in the picture, because having pandas isn't enough. It was bitter medicine. It took me a while to accept this. I actually resisted this message. I loved getting SQL out of my life. When I worked with SQL, I worked with SQL raw strings. I've avoided Python orms because of API fatigue and framework fatigue. SQL Alchemy, even as popular as it might be, is going to be just more framework fatigue for me and far overkill for the many things I want to do in a lightweight database way. Enter the dict, the Python standard library dict data class, and back-ending it with SQLite persistence through the SQLite dict third-party package. Pip install SQLite dict. You won't be sorry. That's right up there with pandas, Python pandas, for me now as general back-end framework that I can't live without, because it makes all that stuff that's kind of poofy in Python data frames. It goes away. You can always dump it to a CSV, but the grief and headache of loading data from a CSV back into a Python data frame, into a pandas data frame. There's integer, float, ambiguity. There's all kinds of weird stuff. But if you have your data in almost any format at all, especially your first pass API call, and your whole response object from your requests package or from your HTTPX package, you just throw that raw data in as a cache, as a local database, call it what you will, but it's so easy and fast and high performance and perfectly keyed to your database keys, which are the keys that were put into some function to make that API call. So you could reproduce the API calls if you wanted from your keys. You could double check. You can do spot checking. You can, just throw that whole SQL database over to some data warehousing thing. That can be a value in turn to some other key value system that absorbs your SQLite dicts. There's so many choices, so many ways to slice and dice things at this point. But the one true way is to get your initial API data calls committed to local SQLite dict database through a key value pair interface provided by the SQLite dict package or equivalent, because there are others like it. I just like this one. And knowing that named tuples make for an ideal key in a key value pair, and those named tuples can say a lot about the API call that was made to fetch that data, and those named tuples need to be pickled to actually go in as a key, can be unpickled coming out and retain all their original usefulness. And what were the keywords on that API call? There they are. What were the sites on those API calls? Where they were. And date range if you want them, and so on. You could even put the function name that this tuple was fed to and make it very meta. Whew. And that is all the first pass stuff of ad hoc Jupyter Notebook, Python, data science, SEO, workstation stuff. It's Pipulate. It's the stuff that, no one ever crosses this chasm. People talk about it. People look at the Python heavyweights in the industry and, covet them and, feel like they could do that kind of work and that it's not achievable by them. But I'm here to tell them it is highly achievable to you. The stuff that these people who have the reputation for, being Python SEO gurus, things have come so far with the tools that starting from scratch, you'll be just as far along as they have become as seasoned, at it over the years. Your muscle memory will develop more quickly because of briefer, more sensible APIs, because of the complexity of things being shoved around just so that what ends up being exposed to you, the user, in defining these deliverables for your, next user, because you're the user of these clever web scraping APIs or whatever you want to call them. And you create deliverables out of it that are then in turn used by the next stakeholder. Now, the next stakeholder generally likes to use web interfaces. They like to go to a website, but that can't always be the case, so sometimes it's a Excel-like spreadsheet deliverable. Now, there are other things in between, and this is an area I plan to master. First, there's Diskette under Python, which lets you load these generic SQLite dictionaries into a web user interface for general exploration. But again, you gotta know SQL. You're generally running raw SQL strings against your SQLite dictionary. So I don't think much of a norm, but you'll learn a little about the SQLite internals, and that can only be good. Even though you're not really creating raw SQL, you're using drop-down menus on auto facet interface. It's really clever. So that's disk cache. It's got some clever name for it. Diskette, just something like that. But SQLite Dix with a automatic, magical, exploratory SQL client feeling a web API slapped on it. Then there's the next step after that, where you actually do some interesting visualizations on the data, maybe some interactivity, and that would be Streamlit, not to be confused with Starlight. Starlight is one of the components under Fast API. Streamlit is magical interactive dashboards for free under Jupyter Notebook that you would think you would use, that you would think that you would have to use fancy JavaScript programming with the D3 library, the D3JS library, in order to get things where you grab sliders and move it and watch the visualization of your data change as you move that slider. That's Streamlit. And then there's just the much simpler bread and butter stuff that's not quite interactive JavaScript dashboards, but is still necessary for visualizing your data. Matplotlib, that comes with the Anaconda Jupyter install. So I need to get more familiar with Matplotlib and things like it. There's a few variations on that. There's Sebring, which lets you do a different set of kinds of visualizations, different data models, the visualizing of different models of data. So Matplotlib and Sebring. And then beyond that, there's this whole world of Bokeh or Bokeh, alternatively pronounced Bokeh or Bokeh, which again, even though it's much JavaScript underneath, lets you use familiar Python data structures with instant fancy visualizations. And this is again where stuff like geodata visualization comes into play. It's easy to put, color heat maps over, literal geographic maps based on population densities and all that kind of happy stuff. So that I want to become more familiar and comfortable with. So all kinds of visualization libraries. I'm into all of them. I want to use, Bokeh, Sebring, Matplotlib, Streamlit, and hopefully not have to go down any deep rabbit holes for all of these. Hopefully the general idea of you got a data model, you got to visualize it, that's your input, here's your fancy output device, there's your fancy user interface. So the main thing is data transforms. The main thing is to know how to make, change over time, things that would work well with sliders. Time sequence data comes to mind, where both the plotting of a sphere and the size of the sphere change over time. So all you have to say is this sphere has these two different attributes. Here's its x and y coordinates over time. And here's its size over time. And if you create a JSON object with a data transform, again, it's just spinning through a list with maybe a fancy list comprehension or something. Now you got a JSON object, which is directly feedable into things like Streamlit that give you these interactive sliders, and you suddenly look like a data powerhouse wizard, although all you're really doing is using these, fairly common third-party Python libraries that are either already there with the Anaconda install or just a pip install away. And yeah, I'm loving it. So I'm gonna really focus in on these super efficient, super magical implied data constructs whose utility is applied to me just by nature of these things work together. So list comprehensions are highly map reducible, already memory efficient, when you can turn them into a generator or a tuple comprehension with parentheses instead of square brackets. All kinds of internals are going to kick in to make sure that you are not using dynamic data types in there, so it's going to be high performance, memory is going to be freed up, the garbage collector will do a better job. And then even go a step further by using the context manager on the internal of the list comprehension. I've got a few discoveries to do there, but I'm pretty sure I've used with open inside a tuple comprehension, inside inside a generator. Tuple comprehensions are generators, same thing. Tuple comprehensions are the API of a list comprehension inside parentheses instead of inside square brackets. Same thing applies for curly brackets for a dictionary comprehension. But if you use the context manager inside a tuple comprehension, you're already in some really highly optimized, asking for highly optimized, memory efficient regions or areas. But if you can go that last step of using the async keyword in combination with the context manager, so it's a function that supports both async and the context manager. So it's not going to be everything. You're going to be looking for client types, session types, iterable objects that expose the API of both the context manager, so it can be used with the with keyword, with open, and sometimes the open is implied, but it's got to be able to be used as with is the context manager. And if it is an async function, so with async function name. Inside a generator comprehension, so it's asynchronous inside a generator comprehension. And you will have something that is one of the most elegant and contained concurrent parallelizable, with the correct stuff to support this statement that I have ever imagined in my programming life. I don't think I've ever tried to do anything cooler. This is perhaps the coolest expressive statement I've ever pursued in programming. And I'm kind of anxious to get home and actually try it. So the key thing is whether the context manager works within a generator comprehension, and in particular whether a asynchronous context manager works inside a generator comprehension. Then I'm going to be doing some massive crawls through a fire hose into SQLite. Am I ever? And I'll be able to do these races between, let's put that elegant Python statement, it's a Pythonic statement, let's put this most elegant Pythonic statement in competition against, say, Screaming Frog, say against Deep Crawler. I'm pretty optimistic about this. I think that I can get high performance crawling using SQL, nothing else other than SQLite, Python, and a couple of pip installed libraries. And it'll be great for site audits, for starters. Anywho, this is where I wrap up. It's a good place to wrap up. I'm very pumped on my work. I'm very keen on what I'm doing. And I feel new wizardly powers starting to kind of percolate up into the forefront of my conscience, where it was sort of resting in my subconscious before trying to express itself, trying to percolate to the top, to move to the forefront of my conscious brain. This concept that if this, then that. If this is possible, then that should be possible. And if that's possible, this other thing should be possible. And because these things all pop their APIs out at different angles from the object, you know, with open as file handle for X for X in list, they should all be the async keyword. They should all be able to be kind of finessed to live together into the same simple statement for some profoundly cool expressiveness, poetry in Python. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.